Integrating factors. The first thing we want to do when solving an ordinary differential equation using the integrated factor method is to get it into standard form. This is the form of dy by dx plus p of x y is equal to q of x, where p of x and q of x are just functions of x. Then we need to create another function, which we're going to call mu of x. As you'll see in a minute, we want mu of x such that mu dash of x is equal to mu of x p of x. So to find out what mu of x is going to be, without having to know mu dash of x, we are going to separate so that p of x is the subject of this function, this equation, and then we're going to integrate. So we've got the integral of mu prime of x over mu of x is equal to the integral dx equal to the integral of p of x dx. We know that the integral of any derivative divided by the original function is the logarithmic value. So we've got the log of mu of x is equal to the integral of p of x dx. Then using exponentials, we can have that mu of x is equal to e to the integral of p of x dx. So this is going to be our value of mu of x. If we go back to where we're solving the differential equation and we multiply both sides by mu of x, that'll give us mu of x dy by dx plus mu of x p of x y is equal to mu of x q of x. Here we notice one special thing about the left hand side. If we have a look at what we've got mu of x, let's call it u, multiplied by dy by dx. And then we've got mu of x p of x, which is the u prime, derivative of u, and then y, which we can call v. Dy by dx will be v prime. So this is the formula for the derivative of a product, where the product will be u equals mu of x and v equals y. So the left hand side is equal to the derivative of y mu of x. If we equate that to the right hand side of the equation, we've then got mu of x q of x. Now we're trying to solve this differential equation for y. So if we integrate both sides, then we will have y mu of x is equal to the integral of mu of x q of x dx. And then make y the subject, so we've got the integral of mu of x q of x dx all over mu of x. And this is our equation to solve a ODE using the integrating factor. Okay, to recap, first step we did was just put it into standard form, then we found out what the function mu of x was, multiplied the equation by mu of x, made y the subject, and then we will solve for y and input any initial values if we have them. Now we're going to do an example. So we're going to solve dy by dx plus 2y equals 13. So first thing we're going to do, it's already in standard form because there is no coefficient of dy by dx. The coefficient is 1, so that's fine. So the next thing we're going to do is calculate what mu of x is. So we can just use the formula we created, which is e to the power of px dx, which in this case is e to the integral of 2 dx. So that's e to the 2x. Then if we multiply both sides by e to the 2x, we've got e to the 2x dy by dx plus 2e to the 2x y equals 13 e to the 2x. Looking at this, we've got u and v, so we know that the derivative of e to the 2x y is equal to 13 e to the 2x. Integrate both sides, e to the 2x y is equal to the integral, 13 lots of the integral of 2x dx, which we can then solve. 13 lots of a half e to the 2x plus c, and then we can solve for y. So we've got 13 over 2 plus c e to the negative 2x, and that is y, as we had no initial conditions. Okay, another question. We want to solve x by 4 lots of dy by dx plus y is equal to x. So if you want to pause the video now and have a go, and then I'll solve it in a minute. Welcome back. Okay, so we're going to solve x over 4 lots of dy by dx plus y is equal to x. So first thing we need to do is to make it into standard form. So we're going to divide by x over 4. That will give us dy by dx plus 4 over x y is equal to 4. Then the integrating factor mu of x is going to be e to the integral of 4 lots of 1 over x dx, 4 lots of ln x, which is just x to the 4, multiply everything by mu x to the 4 dy by dx plus 4x cubed y is equal to 4x to the 4. Looking at this section, so we've got y x to the 4 is the derivative of y x to the 4 is equal to 4x to the 4. Y x to the 4 is equal to 4 lots of the integral x to the 4 dx, which is equal to 4/5 x to the 5 plus c, which makes y 4/5 x plus c x to the minus 4. I hope you found this useful. Thank you very much.